One-to-one functions, the simple definition is if I have different inputs, I'm going to get different outputs. Different x's produce different y's. Looking at it using the function notation, if a isn't equal to b, then f of a can't be equal to f of b. And remember, f of anything is just a y value. So functions mean I'm not repeating my x's in my ordered pairs, but a one-to-one function will also not repeat the y's. Now we're going to use this definition a little bit differently when it comes to solving equations. We're going to say if we have two function values that are equivalent, then they must have started and come from the same x values. The x's are equivalent. Okay, don't worry about that right now. We'll get to it later. Let's first take a look at the graphical implications. Okay, if I have a set of ordered pairs here, a relation 1, 2, and 3, 2, is that a function? Yes, because I'm not repeating my x's. That's the only real requirement to make a relation a function, no repeat of my x's. Is it a one-to-one function? Well, no, because I repeated the y values. And if I graph these two ordered pairs and I join them with a line, it would always produce a horizontal line. So you might remember the vertical line test to determine if a graph is that of a function or not. We have an equivalent here for one-to-one functions. It's called the horizontal line test. And it says if a horizontal line is going to cross more than one time, then it's not going to be a one-to-one function. And the reason we care about one-to-one is because think about what would happen if you took the inverse of this original relation here, this original function. Now we're starting with a function, but when I take the inverse of it, it would be 2, 1 and 2, 3. It wouldn't be a function, right? So only one-to-one functions are going to have inverses that are also functions. So that's why we care. Let's take a look at actually determining if a couple functions are one-to-one. This first one, 3x squared minus 2, we should recognize that, of course, as a quadratic. And I could do a quick sketch of that on my own, or I could just put it in the calculator and quickly see that no, a horizontal line is going to pass several times. In several places, a horizontal line would cross twice, or that's going to disqualify this from being a one-to-one function. If I wanted to verify it algebraically, I would solve for my x. Okay, so I'm going to replace f of x with y, and then add the 2, divide by 3, and then I have to take the square root. And remember, when I'm taking the square root and I'm solving, I have to do a plus or minus. So putting in one y value could result in two different x values, a positive or a negative. So that's how you would verify it algebraically. Now what about this one? X cubed plus 3, well, we recognize the cubic function is that little snake-like thing, but plus 1 moves it up 1, and you could do that again on your own, or you could put it in your calculator, and you see that no matter where you draw a vertical line, it's only crossing once. And it looks kind of flat here, and this is where the part is that we have to know what this function really is. The cubic, it kind of flattens out, but it's not exactly flat there. And again, if you just were uncertain, you weren't familiar with the function, you could verify it algebraically. Solve for the x, subtract the 1, and then take the cube root. There's no plus or minus when you take the cube root, so there is really only one x answer that we get out of this if we put in a y value. Okay, and again, the reason we care about one-to-one is because only one-to-one functions are going to have inverses that are also functions.